So welcome to Homework Solutions video for assignment 3.07 number 2, which are questions 7, 9, and 11 out of section 8.3 of the textbook. In question 7, in 2011, the London Eye was the largest Ferris wheel in the Western Hemisphere. It rises 135 meters above the ground and takes the same amount of time to make one rotation as the Star of Nanchang. How would the graph of a passenger's ride on the London Eye be the same as Simone's graph? How would it be different? So the question is, what's going on with the Star of Nanchang? What is Simone's graph? That is one that was solved in earlier examples and earlier questions. Right here, reflecting number 1. So we've got a 26 meter circumference in reflecting part I. So here is so there's the so it's 26 meters from the circumference. Sketch Simone's graph on the grid, and in the same grid, sketch the graph of the movement of one of the lights. How are the graphs the same, and how are they different? And we have another option, or below, another graph here. So these are all the Star of Nanchang. That's all the examples that we have here. So the time to complete one cycle of the Star of Nanchang is 30 meters. Starts from 0 and goes up to 160. So we have a radius of 80 meters and a period of 30. That's the information we need to make our comparisons and complete the problem. So this is a 30-meter period. In 2011, the London Eye was the largest Ferris wheel in the Western Hemisphere. So here we go. Going back to our Desmos to graph this now. With a period of 30 meters, if we let B be in meters, with a Ferris wheel, I'm going to start with a cosine, because that will allow us to give us just a negative amplitude, and we're automatically starting at the low point without having to do a phase shift. So our C remains at 0. Now B, we want a period of 30 minutes, so that's 2 pi over 30, which works out to be the same as pi over 15. We're going to have to make our x-axis match that. So we'll make this a 30-minute period. Now, this one is 135 meters above the ground. So 135 meters is our maximum. And there's no indication of what the minimum would be. So I think we will take a minimum of 0 and say our amplitude is 135 over 2. So that is going to give us a y-axis going from 0 to 135. With a midline that's also 135 over 2. Sorry, zoom out a little bit. And because we want to start at the bottom, we add that negative. So here we go. Now we can finish the problem. How would this be the same as Simone's graph, and how would it be different? The period and the period and the phase shift are the same. The amplitude and the midline are different. So Simone's graph was similar to this, but it came up to 160 and still dropped down to 0. So slightly higher midline. The midline would be 80 instead of 67.5. And our amplitude is 80 instead of 67.5. So that solves question 7. Now, question 9. We touched on some of that. I'll have to make a note of that. Somehow when I was previewing these, I missed that 9 and 10 were connected questions. So number 9, when you breathe, the air entering your lungs has a positive velocity and the air exiting your lungs has a negative velocity. This is the relationship. So the midline would be 0, represents the average air velocity, which, as we discussed in yesterday's homework solutions, we better hope would be 0 or bad things happen to us medically. The amplitude is the difference between the midline and the max, so that's a 0.8. And the period of this function is 5, so on average, a person at rest takes 5 seconds to breathe in and out. Finally, number 11. A competitive gymnast's coach graphs one particular series of jumps. Describe the jumps using the graph. So we have some pretty consistent jumps where this gymnast is going from, looks like a low point of about 3 feet in the air, so probably on a trampoline or similar. Highest is about 30 feet in the air, and the midline then is close to 18. It should be about 17.5. And it takes approximately 3 seconds to complete a jump. Just running from the graph here. So this is why this is a professional gymnast as opposed to me, because my graph would be, bouncing up and down right at the very bottom there, and not nearly this consistent. But that is the solutions video for homework assignment 3.07, number 2.